Assalamu alaikum. Bismillah Rahman Rahim. My name is Dr. Temia Ayub, and I am going to start with the quote of the day, which says that whoever does something good this month, Allah multiplies it by 70. It is a hadith by mentioned in Al-Tirmizi. So today I will be presenting Test of Significance under kind supervision of Professor Dr. Saira Afzal. So we will start with the outline. So this is the outline of today's lecture, in which we will start with the introduction, then we will do basic statistical concept, then we will go to normal distribution, types of test of significance, which will include t-test, ANOVA and COVA, Pearson's and Spearman's correlation, regression analysis, chi-square test, followed by comparison of parametric versus non-parametric test, and then in the end we will be doing MCQs. So these are the learning objectives of today's lecture, which include understanding test of significance, defining hypothesis, testing concept, explaining different statistical tests, which will include t-test, ANOVA, and COVA, regression analysis, chi-square test, etc. Then differentiate between parametric and non-parametric tests and clarifying their use in research, and then applying statistical methods to public health research and showing real-world examples of significance testing in healthcare studies. So these are the three main resources. As you will be seeing that today's lecture include very difficult concept. So I will be presenting guideline and outline of the main concept, and you can do the rest of the details you can do from these books. So first of all, I will be repeating some very important terms which have already been done in the past few days, but they will be repeating in today's lecture. So I want to go through them very quickly. So we will start with what is dependent variable. The outcome or the variable being measured or predicted is known as dependent variable. Dependent variable is always explained on the y-axis. And then we come to the independent variable. It is the factor that influences or predicts the dependent variable. It is always mentioned on the x-axis. As you can see in the figure also, that the y-axis is also known as the dependent axis or the effect, and the x-axis is also known as the independent axis and the cause. So what is a hypothesis? Hypothesis is a testable statement or assumption about a popular parameter that is evaluated using statistical methods. There are two types of hypothesis: null hypothesis and alternative hypothesis. Null hypothesis assumes no effect or no difference between groups. Alternative hypothesis assumes that there is an effect or difference between two groups. Then we come to types of error. There are two types of error. Type 1 error, which is also called false positive, which rejects null hypothesis when it is true. Then we come to type 2 error, which is also called false negative, which is failing to reject null hypothesis when it is false. So now we come to significance level, also known as alpha, which is the probability of rejecting the null hypothesis when it is actually true. It is commonly set at 0.05 or 5%. P-value. P-value is the probability of obtaining results as extreme as or more extreme than the observed data, assuming the null hypothesis is true. So now we come to the normal distribution. It is also known as Gaussian distribution. The normal distribution is a fundamental concept in statistics representing a bell-shaped curve that describes how data values are distributed in a population. It is widely used in research, data analysis, and hypothesis testing. So the examples of normal distribution are found in nature. For example, the distribution of adult weight follows a normal distribution, with most people having an average weight and few people being extremely obese or thin. Similar is the case with blood pressure. In a healthy population, blood pressure readings tend to be normally distributed around a typical value. As you can see in the figure on the right side, that this is representing the normal distribution of weight in rabbits. So as you can see in the center, we have all the rabbits which have a normal or average weight. On the right side, we have extreme weight of the rabbits which are obese, and on the left side, we have extremely low weight of the rabbits which are very thin. So even in nature, usually the phenomena of nature are normally distributed. So we've already explained these two examples. Now we come to this bell-shaped curve, which I'm sure all of you have already seen, but we will go through it quickly. So this is the phenomena of bell-shaped curve, which actually represents normal distribution. So in the center of the phenomena, we have the average or the mean. And then on the right and left side, we have one standard deviation and then second standard deviation and then uh, third standard deviation. So on the right side, we have +1 standard deviation, +2 SD, and +3 SD. And on the left side, we have -1 SD, -2 SD, and -3 SD. And in the middle, we have mean. So 2 standard deviation, -1 and +1 equal to 68%. Then +2 and -2 standard deviation equal to the 95% of the observation. And +3 and -3 standard deviation from the mean equal to the 99.7% of the total observation. So these are some of the key characteristics of normal distribution. Bell-shaped curve, symmetrical around the mean, and then mean, median, mode. All of them are equal. The peak of the curve is the most frequent value. The normal distribution is always symmetrical. The left and right side of the distribution are mirror images, as you have seen in the previous diagram. And then the tail of the curve extends indefinitely without ever touching the x-axis. This is one of the very important rules of normal distribution. And then we have already explained the 68, 95, and the 99.9% formula. So now we come to the test of significance. A test of significance in statistics is a method used to determine whether the observed result in a study or experiments are due to chance or if there is real relationship or effect between this. It helps researchers make inferences about a population based on sample data. So this is the categorization of test of significance. I have categorized them based on the types of data. So there are two types of data. One is parametric test, and then the other is non-parametric test. Parametric tests are always normally for normally distributed data. They are usually for the quantitative or numerical data. The examples of parametric tests include z-test, t-test, ANOVA, Pearson's correlation, and then regression analysis. Whereas for non-parametric tests, they are non-normally distributed and they have categorical or ordinal data. The examples include chi-square test, Mann-Whitney U test, Wilcoxon sign rank test, Kruskal-Wallis test, Spearman's rank correlation. I will try to explain all these tests one by one now. So now we come to the number one test, which is the most important test, and we use it quite often in biostatistics, which is the student's t-test. A t-test is a statistical test used to compare the means of two groups to determine if they are significantly different from each other. It is used when the sample size is small, that is, the number is less than 30. The population standard deviation is unknown, and the data is normally distributed. So these are the three types of student t-test, which include one sample t-test, independent or unpaired t-test, and then dependent or paired t-test. So now we come to one sample t-test. It is used to compare continuous data with the standard given value. Or we can say that it compares mean of a single sample to a known population mean. This is the formula in which x is the sample mean, mu or u is the population mean, s is sample standard deviation, and n is sample size. So this is the example in which we are, for example, the average height of girls 18 to 24 years in Lahore is 160 centimeter. The mean height of girls in XYZ University is 164 centimeter, according to data collection in research project. In this case, when the value derived from the data set is compared with standard value, the statistical significance of data set will be examined using one sample t-test. As in this example, we are going to compare the collected value from our data set to the known population mean. That is why this is known as one sample t-test. Now we come to the independent sample t-test, which is also called unpaired t-test. It compares the means of two independent or unrelated groups. This is the formula in which mean of one group and mean of second group are going to be compared with their variance and the sample size. Now we come to the paired t-test, which is also known as dependent t-test. It compares the means of same group before and after an intervention. So the number of people or the group of people are going to be the same, but there is going to be a difference in time or an intervention between the two measurements. So this is the formula in which D is equal to mean of differences between paired samples, and SD is the standard deviation of their differences. So this is one diagram which quite simply explains the concept of one sample t-test, independent sample t-test, and paired sample t-test. So as you can see in the figure first, we are going to compare one group of people to the universal value or a population mean value, as we explained in the example of the height of the girls in Lahore. And then we come to the independent sample t-test, in which we are going to compare two different or independent groups and see if there is any difference in their means. And finally, we come to the paired sample t-test, in which we are going to see is there a difference in a group between 2 points in time. So these are same group of people before and after an intervention. So the only difference between this is that some time has passed or some intervention has been done to the same group of people. Now we come to the analysis of variance, also known as ANOVA. Analysis of variance is a statistical test used to compare the means of 3 or more groups to determine whether there is a significant difference between them. It is an extension of the t-test. T-test compares only two groups, but ANOVA compares 3 or more than 3 groups. It assumes that the data is normally distributed and has equal variances across groups. So there are different types of ANOVA. So one-way ANOVA, it compares one independent variable, for example, effects of 3 diets on blood pressure. Two-way ANOVA, it compares two independent variables, for example, effect of diet and exercise on blood pressure. And number 3, we have repeated measure ANOVA. It is used when measuring the same subjects multiple times, for example, blood pressure before, during, and after treatment. For example, a researcher wants to see if the 3 different exercise programs result in different weight loss. A one-way ANOVA is used to compare the mean weight loss across the 3 programs. Now we come to another term which is known as ANCOVA, or analysis of covariance. It is used when comparing means between groups while controlling for an additional variable, also known as covariate. So now what is covariates? Covariates are continuous variables that might influence the dependent variable, but are not the primary focus of the study. It reduces variability and increases statistical power. For example, a researcher studies the effect of diet type A, B, or C on weight loss, but controls for exercise hours, since exercise can also have effect on the weight loss. And COVA adjusts for this extra factor, making the comparison of diet effects more accurate. So now we come to Pearson's correlation, also known as R. Pearson's correlation coefficient R measures the strength and direction of linear relationship between two continuous variables. It tells us how strongly two variables are related and in which direction, positive or negative, they are going. So it ranges from -1 to +1. For example, R is equal to +1 tells us perfect positive correlation. As one increases, the other also increases. R -1 depicts perfect negative correlation. As one increases, the other decreases. And R is equal to 0 shows there is no correlationship or there is no relationship between these variables. It assumes that the data is normally distributed and the relationship is linear, uses actual values of the variable sensitive to outliers, which can strongly affect the results. For example, the correlation between height and weight of individual. As height increases, the weight generally increases. Linear relationship. So this figure is showing us Pearson's correlation with its different value. On the extreme left side, you can see that R is 1 positive. So it means that there is positive linear relationship between the two variables on x-axis and y-axis. And now you can see in this figure, the R is 0.8. The different measurements are still on this line, but they are a little bit farther away, or you can say they are a little bit scattered. When R is 0, they are more scattered. And when R value of R is this is 0.3, and when the value of R is 0, the observed values are very much scattered, and we cannot see any correlation, or we cannot plot any line between them as a relationship. So now we are seeing that in this, the R is going in the negative direction. It is minus 0.3. And when R is minus 0.8, the direction of the line is on the opposite side. And when R is minus 1, there is still a relationship, but it is going in the opposite way. One is increasing as a variable on the y-axis is increasing. The variable on the x-axis is decreasing. That's what this is showing. So now we come to Spearman's rank correlation. It measures the strength and direction of monotonic relationship between two variables. It does not assume normal distribution and works with ranked ordinal data. It converts data into ranks before calculating correlation. It is less sensitive to outliers than Pearson's correlation. So one thing we should keep in mind that Pearson's correlation is for normally distributed data, and Spearman ranks correlation is the same thing, nearly the same thing, but with non-normally distributed data. And it is for the ordinal data, there is going to be ranking instead of the nominal data. So for example, the correlation between student ranking in two subjects. A student ranked first in maths might be second in physics, and another ranked fifth in math might be sixth in physics. So as you can see, we are not going to compare their marks or obtained marks in this. We are going to use their ranks in this type of correlation. Now we come to a very important topic, which is also known as, which is the regression analysis. So what is regression analysis? Regression analysis is a statistical method used to examine the relationship between one dependent variable, which is going to be on the y-axis, and one or more independent variable, which are going to be on the x-axis, as I have mentioned earlier in the presentation. It helps in predicting outcomes, for example, predicting sales based on advertising budget, understanding relationship, for example, how smoking affects lung capacity, identifying trends, for example, impact of temperature on ice cream sales. So there are going to be there are many types of regression analysis, but these are the three main types which we'll be discussing today. Simple linear regression, multiple linear regression, and logistic regression. So first is the simple linear regression. It examines the relationship between one independent variable on the x-axis and one dependent variable on the y-axis. So there are going to be only two variables, one on the x-axis and one on the y-axis. This is the equation, which is quite complicated, but I would like to simplify it for you. So the y is the dependent variable, which is going to be the value coming on the y-axis. X is the independent variable, and then B0 and the B1 are the different intercepts and the slope, or the different factors which are going to be adding up to the independent variable to make it equal to the y-axis variable. So example include predicting blood pressure Y based on salt intake, or analyzing the effects of smoking on lung capacity. So this is the example of the salt intake effect on the blood pressure. So as you can see in the figure on the left side, they have figure for both the systolic and diastolic pressure. If we only take example of the diastolic pressure, you can see if the salt intake is, as it is the independent variable, it is plotted on the x-axis, and the blood pressure, which is the dependent variable, is plotted on the y-axis. And then we are only going to be comparing these two on, and we will come up with a simple line which is showing slightly linear relationship between these two variables. So now there is multiple linear regression. It examines the relationship between one dependent variable, which is on the y-axis, and two or more independent variable, which are going to be x1, x2, till xn. The equation is going to be more complicated than simple linear regression, but usually the statistical software we are going to use, it's going to calculate the multiple linear regression for us. So examples include examining how age, excuse me, how age, BMI, and exercise together influence cholesterol level. So these are the age, BMI, and exercise are the independent variable will be plotted on the x-axis, x1, x2, x3. And the dependent variable is cholesterol level, which is going to be on the y-axis. Similarly, studying the impact of air pollution, x1, x2, smoking, and occupational exposure, x3, on respiratory diseases, which is going to be on the y-axis. So now we come to the logistic regression. So what is logistic regression? It is used when the dependent variable y is categorical. Either the answer will be yes or no, or 0 or 1. The equation is based on the logs or the transformation. The equation is like this, but similar to multiple linear regression, the statistical software will be calculating this. So we are going to, for example, if we are predicting whether a patient has diabetes, yes or no, based on sugar levels. So the answer is not the um, uh, any nominal data or any continuous variable. It is the answer is diabetes, either it is present or not present. So this is the main difference between logistic regression and linear regression. This is a figure which is showing us the logistic regression. It means that there is age in years is the on x-axis, and probability of purchasing health insurance is on the y-axis. So first of all, probability less than 0.5 signifies that people less than 40 years old are not likely to purchase insurance. So this is the no answer, and this is the yes answer, that probability greater than 0.5 means that the people older than 40 years are going to purchase health insurance. So the shape of what I want to emphasize here is that the shape of the logistic regression is like slightly wonky form of S. So this is the usual form of logistic regression, and it usually is the answer of dependent variable is yes or no. So this is again, we have completed the parametric test, and now we are going to be covering the chi-square test, followed by the comparison of parametric and non-parametric tests. So the chi-square test is a statistical test used to examine the association between categorical variable. That is the most important difference. It helps determine whether the observed distribution of data differs from what is expected by chance. And the key assumptions of the chi-square test is the data is categorical, not numerical. Observations are independent of each other. Expected frequency in each category should be greater than 5 for accuracy. And then 2 by 2 contingency table is made for chi-square calculation, which we have all of us have seen. So this is the simple formula of the chi-square test, in which it is sigma observed minus expected value squared divided by expected. So O is observed frequency, E is expected frequency. Example is checking if smoking, yes or no, is associated with lung disease, yes or no. So the answer is present or absent of presence or absence of smoking, association with presence or absence of lung disease. For chi-square test, null hypothesis for this example is no association between smoking and lung disease, and the alternative or H1 hypothesis is there is association between smoking and lung disease. These are the left hand side we have parametric test, and on the right hand side we have non-parametric test. I have taken this table from Madam Dr. Saira research book, and it is very simply explained that there are parametric tests and they have their non-parametric counterpart, and the difference between both of them is that on the left side we have normally distributed data, and for non-parametric tests we usually have non-normally distributed data. So for one sample t-test we have sign test or Wilcoxon signed rank test. For paired t-test we have sign test and Wilcoxon sign rank test and independent t-test, and then we have for ANOVA we have Kruskal-Wallis test. So now we come to multiple choice questions. What is the main purpose of a test of significance in statistics? To calculate the sample size, to determine if observed results are due to chance, to measure variability in data, D, to calculate correlationship between two variables, and E, to compare categorical variables.
D.
B.
B.
Yeah, B.
B?
B is the answer. To determine if
B.
observed results are due to chance. A t-test is most appropriate when comparing more than three groups, two independent or related groups. Means C, categorical variable, D, a dependent variable with multiple predictors, or E, data that is not normally distributed.
Two independent groups.
Yes, it is B, two independent or related group means. So 3, in hypothesis testing, rejecting a true null hypothesis is known as type 1 error, type 2 error, sampling error, measurement bias, or random variation.
Type 1 error.
One error.
Yes, it is
One
alpha
error.
type 1 error. So a public health researchers wants to evaluate the effectiveness of a new diet plan by measuring the weight of 30 participants before and after following the diet for 3 months. Which statistical test should be used to analyze the data? Independent t-test, one-way ANOVA, chi-square test, paired t-test, or logistic regression?
Pair t-test.
Pair
Pair
t-test.
t-test.
Paired t-test.
Yes, it is paired t-test. 5, the key assumption of a parametric test is data is categorical, data is normally distributed, variables have a monotonic relationship, sample size is always small, or observations are not independent.
Well, distribution.
Yes, it is B, data is normally distributed. Which test
B.
is used to measure the association between two categorical variables? Pearson's correlation, linear regression, chi-square test, ANCOVA, or paired t-test?
Chi-square. Chi-square.
It is chi-square test, C. 7, a researcher wants to study the effect of diet types on weight loss while controlling for exercise hours. Which test should they use? One-way ANOVA, two-way ANOVA, ANCOVA, independent t-test, or logistic regression?
And
One way no.
ANCOVA. Yes, it is ANCOVA. Yes, we are controlling for exercise hours, so the test we will use be ANCOVA, or analysis of covariance. So the MCQ number 8 is, what does Pearson's correlation coefficient R means? A, the association between categorical variable. B, the strength and direction of a linear relationship. C, the probability of rejecting a null hypothesis. D, the difference between two means. Or E, the effect of confounding variables.
Linear relationship.
Yes, the strength and direction of a linear relationship. So there are two aspects, strength also and the direction also. MCQ number 9, which of the following is a non-parametric test? Independent t-test, Pearson's correlation, one-way ANOVA, Spearman-Ranks correlation, or multiple linear regression?
Multiple linear regression.
No, Spearman's rank correlation. Yes, which is the non-parametric version of the Pearson's correlation.
Yes.
So the MCQ number 10, if a researcher finds a chi-square value larger than the critical value, what should they do? Accept the null hypothesis, reject the null hypothesis, conclude there is no association, D, convert data into ranks and retest, or E, used a parametric test instead?
No association.
Reject the null
B.
hypothesis. Yes, it is B, reject the null hypothesis. So this is the MCQ key. This is the YouTube channel where I will be uploading the video. And thank you very much for watching my presentation.
Thank you very much,
Thank
Dr.
you.
Tanya. It was a very nice presentation. Any
you.
feedback is highly appreciated.
Extremely well done.
It was a very important lecture. It was a very good presentation.
Thank you very much. I worked very hard, but I took guidance from the 3 books I showed in the beginning. So they have more details, but I wanted to highlight all the basic concepts.
Okay,
This
thank you
was-
very much, all participants. I would request you to join the Saturday research class because Dr. Temia is also teaching in this class, and Dr. Aisha and many other seniors, they are teaching in the research class like this from very baseline. So please join the class. Thank you very much, everyone.
Thank you, Allah Hafiz.